as people grab their lunch and sit down at their desk or whatever they're doing. But I want to thank everybody for joining here for getting started with AWS, this webinar that is sponsored by KEP Training and Anna Kepscher, our friend at KEP Training. I also want to thank Myles Brown for doing this presentation and sharing his wisdom on the subject matter. For those who have not joined the Hardin County IT Professionals Meetup group, I just dropped the link into the chat there. So if you are interested in getting virtual exposure to these types of virtual events and want to see what we've got cooking in the future, we just talked a little bit about maybe a Salesforce webinar coming up and other various topics related to IT. Feel free to join. And for those that are local people here in Kentucky, particularly Hardin County, hopefully in the next 6 months or so, we can start meeting together in some forums together like we did when we first started about a year and a half ago. But more to come on that as things evolve. Anna, I will turn it over to you to talk a little bit about KEP, what you guys got going on, and then we'll get going on AWS. Thank you.
Thank you, Steve. Hi, everyone. I'm Anna Kepshire, and I own KEP Training. And we have been well known for our public classes for years. And one of the reasons why we want to do this is to really kind of share that we have a lot of great partner delivered classes, VMware, AWS, Azure, and we have great partners. So Myles is one of them, and he's going to do this presentation, and it's going to kind of showcase what else we have going on in addition to the great public classes that we offer. So we're very, very lucky to have amazing partner delivered classes and partners. So take it from here, Myles. Thank you.
All right, thanks a lot, Anna. Well, today the topic is getting started with AWS. So we can only get so far in about an hour, and I do want to leave some time for questions at the end. And so think of this as sort of dipping your toes into the cloud. And then from there, you're going to probably want to learn more. And so we'll talk, right at the end about where to learn more. And really that comes down to, talking to Anna and getting some more training. But we'll start with some cloud definitions, find out why are people moving to the cloud, because it is so wildly popular. And just try and get some benefits and some definitions. And then specifically about AWS, how do we get started? What are some of the most foundational services that kind of everybody uses? And I'll do a bit of a demo where I launch a web server into a virtual machine in the cloud, which we call EC2. And like I said, we'll leave some time for questions at the end. So we'll start with some cloud definitions. This is just the standard one from NIST. What do we know about it? It's this. It's ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. That's a lot of words, right? So what are we talking about? When we talk about computing resources, we're talking about servers, networks, storage. So the same things you might have now if you run your own data center, right? But the problem with running your own data center is you're in the business of running data centers. And why does my company have to do that? And your company and their company? We all have to be experts in running data centers. And the big idea of public cloud is to say, no, maybe I don't need to be doing that business. Right? It's not what makes my business different from yours and special, right? So why don't we rely on a company that's really good at building and scaling and securing data centers? And certainly Amazon is good at that, right? So way back, they really started around 2004 was their first service came out. And at that time, people didn't really understand. They said, why is this company that sells me books, building these sort of, message servers and things like that in the cloud? And really what it came down to was Amazon realized that they're really good at selling books and other stuff, right? But in doing so, they became really good at building and scaling and securing data centers. And they said, that's something people would pay for, right? And so that's kind of the big idea, is that I don't have to run my own data center. I can, on demand, say, hey, I want to launch 100 servers that look like this, right? And I'm not dealing with the physical machines at all. And so a big part of it is that I can rapidly provision these and release them. So if I need a bunch of machines, I can get a hold of them and get them up and running in 3 minutes or so. But when I don't want them anymore, I can get rid of them. And the way the economics work, I only pay for how long they're running. That's very different economics than the regular on-premise data center where you say, hey, I need to buy or build a data center. I need to go and buy a bunch of physical machines, pay for them up front, right? So it's a huge capital expenditure. In AWS, what are you doing? You're paying a monthly operating expense, right? So you're trading CapEx for OpEx, which, your CFO may find that very desirable because they don't have to tie up all the company's money in building and scaling up these data centers. And so this is sort of the big idea. Now, when we talk about these computing resources, it's the same sorts of things that you would have on premises in a physical data center. So we're talking about compute and networking. Instead of physical machines, it's all going to be virtual machines. Maybe we can get everybody. Yeah. Okay. Just maybe we got to figure out who's muting. Okay, I think we're good. So we're talking about compute and networking, storage, databases, all kinds of things, right? So what's the real difference between them? Well, when you look in the physical world, it's like I said, large initial purchases. And then over time, you've got to patch those machines, maybe fix the physical machines. You've got upgrade cycles where all of a sudden that hardware manufacturer says, we don't support that machine anymore. You got to buy new machines, right? All of that you deal with the physical machines. In the cloud, there's no upfront investment at all. You can just start and you pay as you go. And so you have this sort of ongoing cost. Now, when you start off, it's probably a very low cost. Over time, you can imagine as your IT needs grow and your storage grows, your bill will also grow. Right? So I can only imagine what the AWS bill that Netflix pays because, since 2009, they said, we're out of the data center business. We're going all AWS. And so, that's a lot of storage. That's a lot of streaming of data, right? But so their bill must be huge, but so would it would be even bigger if they had to run their own data centers. When it comes to things like system administration, fixed capacity, well, wait, actually, here's what I wanted to say about this. Like that idea we said, trading CapEx for OpEx. Right? Next up, system administration. It's a lot of like fixed capacity stuff. In the cloud, you don't worry so much about dealing with the physical machines and everything. Instead, you kind of focus on whatever your company's good at, right? So you stop spending time on the things that you're not your core business. There's no reason for us all to be experts in running data centers, right? The fixed capacity thing, when I buy a bunch of hardware, that hardware can only handle so much traffic. Say it's a web app or something. So I say, okay, I go buy 10 web servers. Each web server can handle so many requests per second. So, I kind of have to look into the crystal ball and make a guess about what my traffic's going to be like in the next couple of years, and then go make a big hardware purchase, right? And then I'm stuck with that hardware that I got. And so there's a lot of procurement and setup of that machines, and it's a fixed capacity. When I need more, I have to go and buy more. And, it takes a while, that process to go. I got to get a PO. I get these physical machines shipped to me. I plug them in. It's a lot of work. In the cloud, it's very flexible capacity. I can launch things really quickly. I can get rid of them really quickly. So it's all about speed and agility. And so when we have that kind of idea where I can launch things quickly, if they don't work out, I can get rid of them quickly. This is very interesting. Because what it means is that the cost of failure is very low. I've run into situations where, I'm more on the development side, but my colleagues on the operations side, we're working on some new application and we thought, okay, this is going to be a real memory hog. So let's buy machines with relatively more RAM than, say, CPU, right? But then in production, we start running the application and we realize it's actually spinning up a lot of cycles. Unfortunately, we bought machines with lots of RAM, not so much, can we add more CPU to these existing machines? Maybe, but you're really going to hit some limits there pretty quickly. In the cloud, I can launch a virtual machine with lots of RAM, and then I realize, oh, I picked the wrong kind of machine. What do? Stop it, and then launch something else. And what did I pay while I made that mistake? Pennies per hour for each EC2 instance, each virtual machine. And so when the cost of failure is low, it really encourages people to experiment more, right? And what you get out of that is a real kind of culture of innovation. And so a lot of times when people talk about moving to the cloud, it comes from the CFO down. They say, hey, I hear we're going to save a lot of money if we go to the cloud. And you're like, well, yes, but you better have a long timeline for that. You're not going to save money today. If you've got a huge IT infrastructure and you're moving to the cloud, you better have timelines of 3, 4, or 5 years to save money. Because for a while, you're going to be running things in the cloud and on-prem, right? And you're going to have to sort of retrain everybody to think about how things run in the cloud. Like it costs money to move to the cloud even, right? But you will save money there eventually, and there's a few reasons why. But to me, the cost savings isn't even the number one reason to move to the cloud, right? That's the sizzle. The real stake is the agility that it gives your IT group, that we can move quickly, we can launch things, we can get rid of them, right? The other last thing is when you build your own physical data centers, you usually build one data center, and then later you say, okay, well, we have some mission critical apps that are need to be highly available. And if some local disaster takes out this data center, the show must go on. So you have to say, okay, well, now I need to build another data center somewhere else. That's very expensive, right? The cost of that kind of high availability means that you're only going to reserve that for the most mission critical apps. Well, luckily in AWS, we already have data centers all around the world, right? So we have global reach right out of the box, right away. And so we can take advantage of that. And it's actually pretty cheap to do a certain kind of high availability, for every app, not just the most mission critical ones, right? So these are some of the main benefits. Let me focus in on this one, flexible capacity, and just make sure we understand that one. So almost everybody's IT needs grow over time, right? Nobody has less data than they had 2 years ago, right? So everybody's needs grow over time, but they don't grow in this nice, linear fashion, right? And in traditional, on-premises data centers, the way we grow is I make a big purchase and then we use those for a while. When we're starting to run out of space, we buy some more, right? And so for a while we have way too much, right? And then after a while we're like, oh, we're running low, buy more, right? But our actual demand curve probably looks something weird like this, where, hey, sometimes we're busier than other times, but over time, our needs are growing, right? And so when we look at the difference between these two curves, we see there's sort of two problems that can come from the traditional purchase cycle, right? One is, hey, I went and bought a whole bunch of machines that I don't even need yet, right? So I spent a bunch of money up front. I probably plugged them all in, and so they're heating up my data center. I got to spend more to cool them. They're sucking power, right? So there is some cost there. The bigger problem is when we're at this situation where, our demand's greater than what we have right now, right? And then customers are going to be unhappy because things are slow, right? And so the big idea in the cloud is that because we can quickly provision and deprovision, unprovision these servers and things, I can kind of match my actual spend, my actual provision capacity just a little bit more than we need at any time, right? That's where the savings really come in, right? Instead of buying a bunch of machines and paying for them all the time, I launch what I need right now, and when my needs grow, I add a little more. When my needs shrink, I get rid of things and I stop paying for them, right? That's where the real savings come from. Okay, so that's the big benefits. This is why people are moving to the cloud, right? So cost savings, more importantly, maybe the agility it gives my IT. Now, some terminology. You've probably heard of some of these, maybe not, right? But you may have heard of people talk about infrastructure as a service, platform as a service. Certainly you've heard of software as a service, right? So things like, Salesforce, that's a perfect example of software as a service. I don't run anything in my own data centers when it comes to Salesforce. I kind of tweak the software they have, but all my data lives there and everything, right? And so if you look at something like, here we're sort of showing, hey, there's a lot of work that you have to manage if you're running all your apps in your own data center. We're talking about operating systems, physical servers, all of that. When we move to the cloud, I can say, just give me a virtual machine. So if you've ever used VMware or anything like that, you have the idea of, hey, a virtual machine is a piece of software that runs on some hosts, and it looks like it's its own computer, right? But I can launch a bunch of them on one physical machine, but they look like multiple machines. And so what's happening there is, in the public cloud, I go to Amazon, or I go to Microsoft, or I go to Google. Heck, I can go to IBM or Oracle or Alibaba. There's lots of public cloud providers. And I say, I want a virtual machine. So I don't think about the physical machines, the storage, the servers. All I get is, hey, here's a virtual machine. You picked what template to launch from. So it's some flavor of Linux or Windows. And it comes up, and I'm the only one that can remote into it. It's completely mine. I can install whatever I want on there. So it looks like it's at my own physical server. And so I can decide what, I have to patch the operating system over time. I have to install whatever software is on there, configure it, do everything. So that's your basic, what we call infrastructure as service. And that's what most cloud vendors focus on. Although a lot of cloud vendors started to look and say, hey, all of our customers are running, say, an Oracle database. So we give them a virtual machine. What are they installing on it? Oracle database. Well, there's a lot of steps to installing an Oracle database and keeping it running that is sort of like the same thing everybody has to do, right? And so they say, well, why don't you let us do that? Instead of letting your cloud provider like Amazon just take care of the physical machines for me, why don't I let them take care of the virtual machine and install Oracle and patch it over time and take nightly backups and, the mundane DBA tasks that I don't want to do. And so what they give me is this sort of managed service. That's what we call platform as a service. So an Oracle database as a service. Here you go. I still am in charge of the data, where it lives, and how to tweak things on top of it, but I'm not taking care of most of it. So there's a lot of these PaaS, platform as a service kind of ideas. Now, finally, software as a service, there's lots of examples. You look out there, you look Office 365, Google has Gmail. I mentioned Salesforce. There's lots of those, right? But public cloud providers, I just mentioned Microsoft and Google, they have software as a service. So does Amazon. Amazon has Workmail and WorkDocs and QuickSight. They've got a few sort of software as a service products. They're not their most popular products, I'll tell you that. Most of the cloud providers are really focusing on infrastructure as a service and platform as a service. Right? So I mentioned, that idea of running sort of a relational database. That's a perfect example of a PaaS. So in AWS, we have a service called RDS, Relational Database Service. So instead of me manually installing and managing the database software, I can kind of get this done for me. And so RDS says, okay, well, the first thing you do if you want to launch a database, you say, well, which of these 6 engines? So Oracle, Microsoft SQL Server, and then, so they picked the 2 most popular commercial databases, so Oracle and Microsoft SQL Server, the 2 most popular open source databases, MySQL and Postgres. So if it's any one of those databases, instead of me having to manage it all myself, I can let Amazon do it. But it's a real trade-off because I'm no longer the DBA. I'm saying I'm going to let a brainless algorithm at Amazon be my DBA. All I get is a JDBC or ODBC driver connection. But I no longer have to worry about virtual machines, operating systems, file systems. I also no longer have access to any of that. So it's a big trade-off. Some people love the trade-off, some people don't, right? It's up to you. The whole point is you get the choice. So I can use the cloud how I want to use the cloud. If all I want is give me virtual machines and I'm going to run everything the way I always have run them, great. If you say, you know what, we got a bunch of developers, we don't have a lot of DBA expertise, we never wanted to hire a DBA because what a pain, right? Then great. You can get a relational database that works and is healthy without paying for a DBA, right? Now, the chief technical officer at Amazon.com, this guy Werner Vogels, he's very quotable, right? He coined this term. He called it undifferentiated heavy lifting. It's the same work we all have to do to get, say, an Oracle database running. It doesn't make my company any different than yours. He said, why don't you let us do that for you? And so some people really, really like that idea. Right? So, if you're running an Oracle database yourself, this is all the work you have to do. Right? In your own data center, you have to have power and cooling and networking. You got to go buy racks and buy servers and stack them up. Somebody has to deal with the physical servers. Somebody has to install an operating system and patch it over time, install Oracle, and then patch that over time, set up your nightly backups. If you don't want it to be a single point of failure, you might set up a second database and set up synchronization between it. Then you got to figure out how to deal with scale. And then finally, the sort of, the user end of the DBA tasks is like, hey, where do I put indexes? Where do I do partitioning? What does my schema look like? Well, in AWS, if I want to run a relational database, like an Oracle database on EC2, that's what we call our virtual machines, then Amazon's taking care of everything up to and including the installation of the OS. And all I have to do is everything else. It's still a lot though, right? And so when I go to that platform as a service, that managed database like RDS, it's just saying, I'm going to let Amazon take care of more of it. And all I'm left with is I connect to the database, I create my tables, decide where the indexes are and the partitioning, and that's about all there is a way for me to take manual backups when I want to take a manual backup or resize things. But for the most part, the heavy DBA tasks are all done for me, right? So there's a lot of platform as a services in AWS. There's one last piece of definition that I want to do, and this is sort of the newest model, what some people are calling function as a service, or FAS. I don't know if anybody calls it FAS, but that's how I would pronounce it. Well, they call it PaaS. PaaS is very popular. And this is this idea of what we call serverless compute. So this is the sexiest thing in the cloud these days, which is, hey, I want to go serverless. Doesn't mean there's no servers. It means that I don't see them. It means that Amazon's taking care of them. So we just saw, hey, with the Oracle database or whatever, I can do that in a serverless way where Amazon's taking care of the servers. Here, we're talking about even the compute part. So in AWS, we have a service called Lambda. And this is very much a developer-centric concept where as a developer, I provide some code. And then instead of ever thinking about servers, operating systems, high availability, deployment, any of those kind of concerns, you just configure, hey, when does this code run? And then you pay for how long it runs. Ooh, got a incorrect piece in here. Sorry, let me just blow that back up. You now pay in 1 millisecond increments for how long that function actually runs. Used to be 100 millisecond, but back in December, they just announced they went down to 1 millisecond increments. So you literally just pay, how long does this code run? And then that's it. Right? So you're never paying by the hour for servers that may be sitting idle, any of that. So it's a very interesting idea. And AWS isn't alone in this. Microsoft Azure and Google Cloud now have this kind of concept of cloud functions. But we can get to a point where you can say, hey, I can even build a whole web application where all the business logic is in a bunch of these Lambda functions. And I put this API gateway in front of it where, again, I don't think about servers or anything. I don't even run Apache or Nginx or any of those kind of web servers. I just go into this AWS service called API Gateway and I say, hey, if they come in with this URL and a get, call that function. If they come in with this URL and a put, call that function, right? And then the business logic's in these little Lambda functions, and then they talk to the back end to some database that's managed. And so you look and you say, where is Linux in all this? Where's Windows in all this? It's nowhere, right? Nowhere that I'm dealing with. It's a very interesting idea, right? The only place where you're going to see the operating system is, whoever's sitting at a browser, and they might be using a phone or a laptop or whatever, but that's not my concern. My whole IT group could be serverless. That's great. I never liked paying for, Linux administrators anyway, right? It's a very interesting idea, and I've got colleagues that devoted their life to operating systems. They were Solaris instructors, then they became Linux and Red Hat instructors, and I had one of them sit in my class a few years ago when this kind of function as a service started taking off, and they said, you know what? I always thought that not every one of these organizations needed expertise in Linux. And that's what we're getting to, where we say, let the cloud provider deal with operating systems and physical servers and all of that. And I don't have to worry about it. So it's a very interesting world. Now, it's a scary world because it's different. And so not everybody wants to jump headfirst into this. Right? So most people, their first move into the cloud is what we call a lift and shift, where they say, take the apps that we have now, look at the physical servers they're running on, go launch virtual machines that look just like that, and move the apps into the cloud. Okay? And that gets you into the cloud. You learn about the cloud, but it doesn't really take advantage of all the benefits of the cloud. And then, you might save just a little bit of money over time, right? But once you start to optimize for the cloud, that's when you see the real savings. Now, before we go too much further, last piece of terminology is, what does AWS's global infrastructure look like, right? So first, it starts with data centers. So they build data centers. Sometimes they'll build one, but usually they build a little cluster of them right beside each other, right? And then miles away, maybe a few towns over, they'll build another cluster of data centers, right? So that cluster of data centers, they call an availability zone or an AZ. Right? So the idea is that this cluster, they're close enough that the next AZ is, like I said, maybe a few miles away. Close enough that, within an AZ, they're close enough together that they appear as one data center. Then, we make groups of these AZs within a few miles of one another. We call that a region. Right? And there, the idea is that one AZ is close enough to another that Amazon can run really low latency lines between them. So I can replicate data from one set of data centers to the other pretty quickly, right? So they have low latency, high throughput lines between them. But things are far enough apart that if there's some local disaster that affects this cluster of data centers, hopefully it won't affect this one, right? And the big idea here is, it doesn't matter what the local disaster is. Could be, hey, somebody's digging next door with a backhoe and pulls all the cables out of your data center. It could be a flood or whatever. So when they build these data centers, they try and build them to be completely as independent as possible. So this availability zone might be on one side of a fault line and this one's on the other side, or they might be in different floodplains, or if possible, connected to different electricity grids even. Anything they can do to make sure that if this group of data centers goes down, the next one doesn't. And then when we go to use these things, we want to make sure that anything we build that's important is not running in just one availability zone. We can say, hey, I want to launch a cluster of 10 web servers. I'm going to span that across at least 2 AZs. And so we might have 5 web servers running in this group of data centers and 5 running in that group of data centers. And that way, if something goes wrong, we've still got servers. We can bring up more over there. Now, AWS currently has 24 regions around the world with 80 availability zones. And you can see the current list. Here's the global infrastructure where they sort of describe it. They have some maps where they can show where the regions are. You'll see there's 7 in North America, there's 1 in Canada, and 6 in the US. And if you hover over one of these regions, it'll tell you how many availability zones. Most of them have 2 or 3. Northern Virginia is sort of the biggest and oldest site that AWS has, and there's actually 6 availability zones. Not that you would ever need that many. Most people only use 2 or 3 for their application. Okay? But you can get more information on these. Normally, what this means is, hey, how am I going to choose where to run my stuff? You start with the region. You say, well, typically it's latency. If all of my customers are in Asia, then I'm not going to run a bunch of data centers out of Northern Virginia. I'll go run them over here in Tokyo or something, right? Next up, it's probably something to do with like data sovereignty, right? I might have some rules that say this data cannot leave the US. So I had better, make sure that I run it in data centers that are US based, right? Then you still have choice, right? Because we got some on the West Coast, some on the East Coast. It might be, proximity, right? To wherever my customers are or to where my data centers are. And then the last thing, there are some services that, not every service is available in every region, right? So, some regions, like there's special ones here for GovCloud, they only have the services that have been heavily vetted by Department of Defense for things like ITAR compliance and stuff like that. So you may actually have to run in one of those GovCloud if you're doing business with the Department of Defense, right? But if you're not doing, just general workloads, you might not want to run it there because it doesn't have all the services you need. And there are some slight price differences. Inside the US, the prices are almost all the same, except this one in Northern California. I mean, you could imagine running a data center in like Palo Alto is a very different pricing scheme than running one in the middle of nowhere in Oregon, right? You got different labor costs, different electricity costs, different real estate costs. And so the only reason anybody runs something in Northern California is because they are also running a bunch of data centers in Palo Alto, and they need really fast data moving between their own data center and Amazon, right? And so it's a bunch of big tech companies that use that one. You'd be a sucker to use that if you didn't need that, because it's a little bit more expensive, right? So that's a little bit about the infrastructure. All right. So getting started with AWS. Well, let's talk about some of the foundational services. Right? I've mentioned this a few times, EC2. EC2 stands for Elastic Compute Cloud. Does that help? Not really. Whenever you see EC2, think virtual machines, right? That's what it is. I don't know why they didn't just call them VMs, right? That's what Azure calls them. That's what kind of Google Cloud calls them. But, we've got EC2, right? So that's that idea. Hey, it's a virtual machine. It's either based on, some image that is either Linux or Windows, or actually Mac OS now. They just added that a couple months ago, but they're super expensive. Right? The idea is you get this virtual machine, you can log into it. So if it's a Linux, I can SSH in. If it's Windows, I can remote desktop in. And I can install whatever I want, run it however I want. Nobody else can get in there. Right? The other way to do compute, we said, was the serverless way with Lambda, where I just say, here's some code, run this whenever this event occurs. Right? Now, these virtual machines can't just run, floating around anywhere. I need a network for them. And so you can imagine that when it comes to networking, everything we do is software-defined networking, right? Certainly inside Amazon's data centers, they got switches and routers and all that kind of stuff, but we don't really know, we don't see that, we don't have any access to that. Everything we do is sort of software-defined networking. And one of the things we can do is build our own virtual private cloud. That's what we call our network. And we get to decide what is the IP address range for all the private IP addresses look like. You're totally in charge of all the networking aspects in that part of Amazon's cloud. Now, this is sort of something that, let somebody in there. If you're not a networking person, then getting deep into the weeds of VPC, you're like, it's beyond me, right? The whole thing is this: your networking people will love it because they can treat that part of the cloud as, just another data center. So you might say, okay, well, we've got an IP addressing scheme. Everything in this data center, the IP addresses start 10.1.something.something. Everything in this data center is 10.2.something.something. And then when we create our VPC in the cloud, we say, okay, all the addresses there are 10.3.something.something. So there's not going to be any conflicts. I can connect from my own data center into the cloud and do all that stuff. The other piece of networking is the concept of a load balancer, right? In your own data centers, this can be either a piece of software or a piece of hardware, right? In the cloud, it's all software defined. So I could use any kind of software load balancer, launch that on some virtual machines, set it up, or I can use the nice service that they provide for us called ELB, the Elastic Load Balancer. It's got lots of nice benefits. I don't have to use it. I can use my own software-defined load balancer. When it comes to storage, we've got lots of choices. Probably the most obvious one is when I get a virtual machine, that's running on some physical server, it might have access to the disk right there on that. So we call that instance storage. The EC2 instance, some of them, depending on the type, come with some free storage that's really fast. The problem is it's not persistent, right? Anything I do that decouples this virtual machine from the physical server it was running on. So if I stop it, I terminate it. Those are two different things. Terminate says get rid of it forever. But stop says, hey, stop it. I can restart it later. I just don't want to pay for it right now. Anything like that, we lose whatever was on disk. So normally for regular disk drive stuff, we use something called EBS, Elastic Block Storage. And then there is this other weird, it doesn't really match to anything you might have in a physical data center now. But S3, that stands for Simple Storage Service, is this sort of object storage for very high durability. So that's probably enough to make us dangerous. I'm going to show you a little demo where I launch a virtual machine. Actually, you know what? Let's talk. We've got a couple more foundational services, and then we'll jump over to our demo. When it comes to security, basically everything we do in AWS is an API call, right? Whether we're doing it through the management console, we'll see that there's this nice, web browser-based, where I say, hey, I want to come into EC2 and I want to launch an instance, I want to launch a virtual machine, right? And so they have a nice, I say launch instance, and it says, okay, I'll take you to a nice 7-page wizard where we ask you some stuff and it ends with us launching your virtual machine. So anything I do in this management console, I can do the exact same stuff using a command line interface or programmatically, so if I've been writing code in Java or Python or C# or whatever language, we have SDKs, standard development kits, and all those. And no matter how I'm doing it, whether it's the management console, the command line, or programmatically through an SDK, they're all doing the same thing under the covers. They're making a RESTful web service call and calling an API that says, do this, right? So everything's an API call. That's why it's called Amazon Web Services. Everything is a RESTful web service call, right? And to secure it, we have a service called IAM, and it basically gives authentication and authorization. It says who's allowed to make what API calls. And so we can set up users, put them into groups, and then dole out permissions, who's allowed to do what. The other thing around security is, data security. Right? We're worried about data security when it's in transit, so we usually use, SSL or something for anything where we're moving data around. But also when the data is at rest, that's our biggest concern. And that side of things, we have a service called KMS, Key Management Service. Lets us manage the keys that get used for encrypting data at rest. And it's hooked in nicely to all the different services that store data. When it comes to databases, we talked about RDS. We saw that it's a nice PaaS offering to give us a nice managed relational database. When it comes to NoSQL databases, we've got DynamoDB and about 8 others. We got a lot of NoSQL databases. And you might look and say, well, that's a lot. We don't use a lot of NoSQL databases. Well, once you move to the cloud, you might start, right? One of the other things that the cloud really does is it tries to democratize advanced technologies. So I think about 9 years ago, I was at a company, we were mostly using MySQL databases for storage. And we had this app that was doing a lot of, reading and writing of JSON files. And I said, I bet this would be perfect for the NoSQL database called MongoDB. It had come out a year or two before. I had read one article on it, and I said, I bet that would be great. Well, at this company I was at, it was like pulling teeth to try and get, hey, I need like 3 or 4 Linux boxes. I'm going to go build a cluster for MongoDB and try this out. And I'm not even sure if I want to do this. As a developer, I had to figure out how to install and configure and manage MongoDB just to see if we wanted to use it. In the end, it was okay. It didn't really do much better than what we were doing, so we scrapped it. So it was a lot of work to get the machines. It was a lot of work to figure out how to do the basic administration to get this thing running. When I moved into the cloud and I started using AWS a lot around 8 or 9 years ago, I saw DynamoDB was there. And I said, hey, that's a NoSQL database. How do I use it? I clicked on it and it said, create a table. I gave it a name of the table and what does the primary key look like? And that's it. We're up and running, right? I don't think about the storage. The storage grows unbounded. I don't worry about, physically how many machines are there under the covers. I don't know. I don't care, right? And so I could get up and running. And if I didn't like it, I just turn it off, So it makes it really easy to try new things, right? Again, it comes back to that whole culture of innovation that this cloud is going to engender in you. And so that's some of the really cool stuff that's there. And these days, in moving to the cloud, a lot of people start to embrace microservices, where each microservice stores its data in its own sort of data storage. And this microservice might prefer a graph database. This one wants a key value store. This one wants a document style, and so we can have different NoSQL databases for different microservices. That's all possible, and the cloud makes it really easy. All right, I promised a bit of a demo, so let's jump into it. Let me bring up my management console. So it's not too hard to get up and running. You do have to create an account. All you need for an account is a valid credit card and an email address, and you give them a password, and then you come in. Now you'll notice right here I'm in Oregon, but there's 20 different regions I can go to. The 4 special regions, there's 2 in China and the 2 GovCloud in the US. You have to fill out a form to say how and why do you want access to it. But the other 20 regions, hey, I'm welcome to do anything I want. So right now I'm in Oregon. Class Demos is the name of my IAM user I set up, for demos. And, I imagine it's very daunting for somebody brand new to AWS. When you first set up your account, you get in here and you look and you say, wow, there's like 200 services here. Do I have to learn all this? Here's a hint. No. I'll tell you, like 9 years ago when I started in AWS, there was about 8 things in this list. So learning all of AWS wasn't that daunting. But it turns out there's a lot of stuff here that you'll never use, right? They're very niche things. Like if I look, here, look at this one, satellite, ground station, communicate with satellites. I'm never doing that. RoboMaker, develop, test, and deploy intelligent robotics applications. I'm not doing that, So there's a lot of niche services that are sort of PaaS offerings for a specific vertical that I'm never going to touch. But there's about 12 to 20 services everybody uses, like EC2. Right? That's our basic virtual servers in the cloud. So if I click on that, that takes me to a specific specific management console just for that. And it shows me, hey, what do you got running? I don't have anything running. I've got 9 security groups, but security group doesn't cost anything, so I just forget to remove them. A security group is basically a set of firewall rules. And whenever I launch a virtual machine, an EC2 instance, I have to launch it into at least one security group. And that's what says, hey, what ports are open? What kind of traffic are we allowing in? By default, the security group doesn't allow anything in. So you have to go and poke holes in it and say, hey, I want to open port 22 so I can SSH into this Linux box. I want to open port 80 so that web traffic can come to my web server, that kind of thing. Right, so I don't have any instances running, so I'm going to say launch instance. And as I mentioned before, it takes me to this 7-page wizard. Right? Starts with the first page, choose an AMI, an Amazon Machine Image. So this is the template. What's going to be running when this instance comes up? And I can build my own AMIs and decide what software is going to be on there. But I'll start with the quick start ones. These are the sort of bare bones ones from Amazon that are basically just an operating system. So they've got various flavors of Linux. Like here you see Amazon Linux, but if I scroll down, you'll see Red Hat and SUSE and Ubuntu. And then there's different flavors of Windows. So Windows Server 2019, 2016, probably 2012, all those ones. And now the newest one is that we have some Mac OS ones. Right? But like I said, they're pretty expensive. They don't show the pricing here. We'll see the pricing separately. So let's say I'm going to launch, I don't know, a Windows server. We'll start with Windows because everybody's seen Windows before. Actually, you know what? No, let me just launch a Linux one. So I'm going to launch a Linux one. And it says, okay, second step is to choose an instance type. So this is kind of like if you were going to buy hardware. It's a trade-off of cost versus how much CPU, how much RAM, how much storage, what kind of networking capabilities, right? And so they break them down into different families. So there's the T2 family, and they range in size from the T2 Nano up to the T2 2XL, right? And so they all have kind of the same mix, but just different number of things. So here the 2XL has 8 virtual CPU and 32 gig of RAM, which is roughly twice what the XL has, which is roughly twice what the large has, you know. And so this is showing me how many virtual CPU and how much memory. Now, we got a few different sort of general purpose, the T2s, the T3s, the M5s. Then we have some families that are more, say, compute optimized. So if I know that I'm going to be spinning up a lot of cycles, I might want to use the C5 family, where they have relatively like a lot of CPU compared to how much RAM they have. Or maybe it's the other way around. Maybe I want the R5 family. Let me scroll way down to the R5s. MNR. Okay, there's the R5s. And so, you know, for a 2XL, again, it has 8 virtual CPU, but now it has 64 gig of RAM, right? And you can get crazy. There's ones that have a crazy amount of RAM. Let me find the X1Es. Look at this. The X1E 32XL comes with basically 4 terabytes of RAM, not 4 gig, 4 terabytes of RAM. Like, this is a monster, right? To go buy a physical machine like this would cost you $1 million. Now, this thing is expensive. It's about $26 an hour to run this thing, you know, as opposed to the smallest ones, like here, the T2 Nano is about half a cent an hour, right? So you got a wide range, and you've got ones that have GPU, you know, so there's a lot of choices there. Only one of the choices is free tier eligible. So when you first create your account, for the first 12 months, they'll give you some stuff for free, right? And so let me just choose that one. And then configure the instance. You say how many instances, where to run it, things like that. If you want, you can provide a little startup script like I'm going to do right now. I say hash bang. This is a startup script. I'm going to use the bash shell, and I'm going to do a yum install of HTTP daemon, so the Apache server, and then I'm going to say service HTTP daemon start. Right? So this basically sets up a web server. Now, in real life, I would go download from somewhere a zipped up, you know, web app, and then go in, put it into the right place, and set up the permissions. But as it is, you know, I'm not doing much here. So right now, I'm going to have that root drive, which is 8 gig, but I could add other EBS volumes. And then I can give tags. So it's not a bad idea just to give it a name tag and call this, I don't know, web server 1. Oops. How did I misspell web so badly? I can make other tags. I can say, okay, what department is this for? This is for the training department. You know, and then, you know, instead of just getting a bill at the end of the month that says, here's how much you owe for EC2, I could say, let's go build a report that shows me how much I owe by department or by project or by developer or whatever. Right? Last step here, configure a security group. You have to run in a security group. You know, if the networking people built those, I would go choose one, or I could create a new one here. Here, by default, they open port 22, so I can SSH in. I can add a rule that says, hey, I want to open port 80 for HTTP to anywhere. Right? And that means anybody can come in on port 80, which is good because that's what I need for a web server. All right, I'm ready to launch. It says, okay, do you have an existing key pair, or do you want to create a key pair? So this idea of a key pair is to be able to SSH in. You know, I need a public key that Amazon has, and I keep the private key. If I haven't built one, I can create a new key pair right now. And I could, here, let me just call it, I don't know, March 18th KP, so I remember to delete it later. it won't let me continue until I download the private part of this public-private key pair. So I'm going to download that into a file stored in my, and now they'll upload the public key. And so if it was sort of Windows, they would generate an administrator password. They would encrypt it with the public key, so only somebody with the private key could decrypt it. So if I go take a look at this instance now, let's see, loading instances. Okay, I have one instance. It comes up, it's pending. If I keep waiting a little bit, oh, now it's running. Okay. So if I select it, I'll get a lot more details. And so here are the details. Here's the public IP, the private IP. So by default, it gives you both a public and a private IP address. If I tell it to open the public IP address, it just opens another browser with that IP address, and it's transferring data. I may have jumped the gun because even though it said it was running, it was probably still running that script I gave it in the background. So let's just give it a second. So impatient. Hit enter again. It's up and running. It's still initializing. So, it's a little early to come looking for it. But, there's my web app. Oops. This is really messed up. I don't know why I've got this extra thing. Oh, I see. Okay. Let's see how we're doing here. Let me reload this. I knew I jumped the gun a little early. But anyway, so it's still coming up. It's got to launch that stuff in the background. All right, we'll come back to that in a minute. Let's pick up with the slides again. So we're near the end here. Let's talk just a little bit. AWS has a bunch of different certifications. They used to have just, associate and professional level. They added kind of a really foundational one called the Cloud Practitioner. All these exams are achieved through multiple choice certification exams. You can separately purchase those, and then you can take them either at a test center, or these days you can do them all proctored from your own home. So we have these sort of 3 different tracks that they try and send you to for architect, operations/administration, or developer. And then there's sort of professional ones. There's also these specialty ones for things like machine learning or data analytics, database security. And basically, most of these certifications have a course that maps pretty closely, either a 3 or a 4-day class. And, we've got a lot of courses. Most people start with a 1-day class, either the Tech Essentials or the Cloud Practitioner. The Cloud Practitioner is for a little less technical people, and also maps nicely to that certification. Then you've got the architecting, the sysops, and the developing. Those are the 3 tracks that will get you ready for those associate level exams. And then the DevOps engineering and the advanced architecting would get you ready for the professional ones, although the professional exams are very hard. You better have actual experience. One of the things they found was that, architecting is a 3-day class, so is the advanced architecting. People were always asked for that jammed together in a 5-day class, and now we have that. It's called the Architecting on AWS Accelerator, with a very intensive 5-day class. And then we got a bunch of other classes that kind of map to the specialty stuff, So machine learning, data warehousing. Data warehousing, this is just a 3-day deep dive on Redshift, whereas the big data is on the rest of the data analytics stack. One of our newest classes is the EKS class. Amazon has its own managed Kubernetes service. You better know Kubernetes before you take that, and a little bit about AWS too. We now have a cloud financial management for builders. So, if you're a team lead who technically knows about AWS, but also needs to figure out how to get the cost down. And the newest class that just came out is called Developing Serverless Solutions. Solutions, plural. And it's really about Lambda and API Gateway and those kinds of things. And so KEP Training has chosen ExitCertified. ExitCertified is an AWS Training Partner of the Year. That's who I work for. But KEP will sell into our classes. We have the largest guaranteed to run schedule of authorized AWS classes in North America. Currently, they're all virtual training. right? We do have training centers, but right now we're doing just virtual training. But we've been doing virtual training for a long time. Since 2012, over 44,000 people have come through using our IMVP platform. If you're looking for courses, here it is, keptraining.exitcertifiedtraining.com/IT training/AWS. And I'm sure Anna will put that link into the chat for you. And so you'll see, architecting, data analysis, security, whatever it is. Most people start with one of the sort of, either the cloud practitioner or the tech essentials, and then from there move on. All right. I guess I'll take questions, and then Anna's on as well. She can take questions if it's more of a sales question. Great. Let's see how we're doing here with my my web app. Oops. Where'd you go? Find that thing. Oh, wait, wrong browser. I'm looking for Firefox. Here we go. Okay. Now let's load this thing. Timed out. I wonder what I did wrong. I might have done something wrong in my demo. Now, let me just take a quick look at the bin bash yum. Oh, I forgot the word install. Nobody caught that. Okay. Well, no wonder my web server didn't install. I didn't actually install it. Okay. Well, you get the idea.
Yeah.
Yeah.
I have a question. I saw that VMware and AWS have a partnership.
Yeah.
So I see a lot of people doing both.
Yeah. So this idea of running virtual machines is very popular inside data centers. Like, in the early 2000s, VMware really changed how people run data centers. And then the cloud came along and said, hey, we're changing things again, right? And so one option is to just launch some stuff in the cloud, launch some stuff in VMware if you're in a hybrid environment, but then you've got two different ways to manage it. And what VMware said is, what if we run VMware's VMs, but in AWS? So they have VMware Cloud on AWS. And so from one pane of glass, I can decide, hey, I want to run this virtual machine on one of my own physical servers or in AWS. And so that's what VMware on AWS is. And so VMware has a class on it. It's a 3-day class. It assumes that you know a bit about VMware. It also assumes that you know a little bit about AWS. So we usually tell people, take the SysOps class, to understand the basics of administration of AWS, and then take the VMware on AWS class. And so for people who are using that particular product, VMware on AWS, as a hybrid solution, it is very popular actually, because it gives people it says, hey, you don't have to forget everything you know, right? You can use that same knowledge of how you manage everything in your own private cloud in the public cloud. There's a few of those kinds of ways where people say, hey, I want to manage stuff the same way. I don't want to rely on how AWS or Azure do things, right? I'm going to launch. And so like something like OpenShift is another kind of, Kubernetes-based concept where they say, hey, instead of relying on the cloud vendor for your platform as a service, we'll have this framework provided. And then I can run that on-prem or in any cloud, and it always looks the same. So these are some hybrid kind of, if you've got private and public cloud, some of the solutions people use.
Awesome. Yeah. Steve, I think we're ready to wrap up. It's unless we have other questions.
Yeah, I sort of, let me flip over. I might be missing questions in the chat here.
I haven't seen any questions in the chat. If anybody has a real quick one, feel free to throw it out there. We're about at the top of the hour.
Myles, can you send me the deck? Because I'm going to pull some of the slides. Marketing.
For sure.
Thank you.
Yeah, and you might want to give it to people who registered or whatever, but couldn't make it.
Absolutely. Okay.
I also see that you guys have the recording started. So is it going to be shared as well?
I need to figure out, we just switched how we're doing these recordings at Jack Henry, so I need to figure out if I can make it available. If I can, I definitely will, and I'll let everybody on this event know about that on our Meetup page, on the event page. So I dropped the link earlier in the meeting into the chat. So get to that event and add yourself to that event, and what I can do is add it to the discussion there if I'm able to make it available outside. So
The recording?
yes.
Okay, well, I think we figured it out last time.
Okay. All right. Well, Myles, wonderful job. Thank you so much for taking the time to put this presentation together and share with everybody. It's been wonderful. A lot of great things you were able to cover in an hour. So way to go on that.
Just got it in.
Just got it in. Just got it in. But thanks for showing the simplicity of how quick you can get things set up there and rolling. And Anna, thank you for sponsoring this event with KEP Training, and appreciate all of you joining, and look out for new events being announced on our page here very soon. Thank you.
All right, thanks for having me.
Thanks. Bye-bye.